since the range is going to contribute about 10 point something percent in the test range and the inverse, I've realized that it will be fair if we would look at a couple of problems about range calculations. I've compiled this list, which is about 9 problems on the range calculation, and the first 6 we're gonna solve the first 6 using inverses, and then the last 3 we're gonna solve it using composite functions. Now, let us start with the first question, but before I do that, I want you to take a look into these problems here. Let me minus it. And then here, I want you to copy these problems, solve them, and then after you have solved them, then you can actually continue with the video to see if your solutions are the same as the solutions that I get from here. If the solutions are different, of course, you can try and look at where did you make a mistake, or also maybe you analyze this video and see where I actually made some few mistakes. Of course, this is not, it's all about all of us learning, and also the guide for you on how you can calculate the range. Let's start with number 1 here. I have my f of x, which is equal to the 7th root of x minus a 5. Of course, we're going to assume that these problems, we cannot plot these functions, so we can either use the inverse or the composite functions. So the first step, we change this f of x to be y, and then we keep everything else as the 7th root minus a 5. Second step, we interchange x and y. Where there is y, I'm going to place an x, and then I have the 7th root y minus a 5. And then the next thing that I will do, I want to remove this 7th root by giving x the power 7. And then what I did on the left, I want to do it on the right hand side, so that these equations remain the same. So I have this nice thing here. This 7 and that 7 will cancel out. Now we'll have x to the power 7 is equal to y minus a 5. And then I take this minus 5 and transpose to the other side. When it's jumping the equal sign, it becomes positive. So I will have 7 x to the power 7 plus a 5 is equal to y. Or let me just say, interchanging both sides, I will have y is equal to x to the power 7 plus a 5. And then, of course, if you look into this function here, it says that actually the inverse, we are actually going to get x to the power 7 plus a 5. Now, even if I were to plot this curve here, it wouldn't be a big deal, because this curve actually looks like this. Just having a rough sketch here is not it's not drawn to scale. This 7 looks like kind of a cubic, but now it bends a little bit towards the y-axis, and then here it also bends towards the y-axis compared to the cubic. But because this is odd, they have the same shape. But now having a plus 5, it means that this point here is moved a couple of units here to 5, and then I still have something like this, and all the other points are moved a couple of units up, and then I'm gonna have a graph like this. So this one is y is equal to x to the power 7. This one is going to be y is equal to x to the power 7 plus a 5. Now, if we want to find the domain of this, we can either look into this function here. As long as I keep cutting the x-axis, I will find out that I will always gonna cut this curve. Or I can plug in both the negative values here. If I plug in a negative value, this will be defined. I plug in a positive value here, this is going to be defined. I plug in a 0, this is always going to be defined. So the domain of the inverse is just going to be x is an element of real numbers. In other words, taking all the values of x. Which means now, because the domain, when you are taking the inverse, you are interchanging x and y. You are interchanging the domain and the range. So the domain of the original function is actually the range of the inverse. and the domain of the inverse is actually the range of the original function. So our original function f is supposed to have a range where x is now is going to be y is an element of real numbers. So this is the range we were looking for question number 1. Now let's look at question number 2. Question number 2 was saying we have f of x is equal to x to the power 3 divided by 1 plus x cubed. So we have x cubed divided by that. Now, of course, we're going to change this and say we have x to the power 3 divided by 1 plus x to the power 3. The next thing we do, we interchange x and y. Where there is y, plug in x. Where there is x, I'm going to plug in a y. And then I have 1 plus x. No. This is supposed to be y cubed. Now that I have this, all I need to do, I have to just cross multiply. I will have x, and then I'll have 1 plus y cubed is equal to y cubed. Expand this, I will end up having x plus xy cubed is equal to y cubed. And then once we have this, I want to group things that have y together on one side and everything that doesn't have y on the other side. So I will end up having xy cubed minus y cubed is equal to minus x, because this one was positive. When it's jumping the equal sign, it becomes negative. This one was positive. When it's jumping the equal sign, it becomes negative. So here I will factorize y cubed. When I'm taking this y cubed out, I'm left with x. When I'm taking this y cube, I'm left with a 1, and then this side I will have that x. Then y cube is going to be equal to minus x. I'm dividing on both sides by x minus 1. When I'm dividing by x minus 1, this side I will be left with this. When I'm dividing by x minus 1, that side I will have that. Now, I don't want y cube here. I want y. So I take the cube root on both sides. So this side I will have the cube root of minus x divided by x minus a 1. Take note of this. Here I have an odd number. So this one is odd. So whenever you have an odd number here, which is the same as that, we don't have a plus or minus in front, which means that whatever is inside here, I can always take the cube root of a positive number. I can always take a cube root of a negative number. The only issue that I have will be in the denominator here. So basically, the inverse function of x here is just going to be, this is 1. The inverse function is just going to be cube root of minus x all over x minus 1. Again, whenever this number here is odd, like 3, 5, 7, 9, I can plug in negative values here inside the root. Is going to be defined. I can plug in positive numbers, it's going to be defined. I can plug in 0, it's going to be defined, which means the cube root is supposed to be defined everywhere. But now I have a fraction. This fraction here is only defined when the denominator is not equal to 0. So if the denominator is equal to 0, this is going to be undefined, which is the only case this one is going to be undefined. So the domain of this inverse here is supposed to be x is an element of real numbers such that x is not equal to 1, because in this particular case, this is x is equal to 1. This is going to be undefined. But if this was 2, 4, 6, 8, 10, that was going to be a different case, because what is inside here, if this is odd, must always be greater than or equal to 0. So that will be a different case. So here, because the domain of the inverse must be equal, must be the same as the range of the original function f, then the range is going to be y is an element of real numbers such that y is not equal to 1. Now, the third question was f of x. We had f of x is equal to ln of x squared minus a 9. This is a 9. My 9 is a little bit cute, but of course, yeah. We have this one here. Let me look into this. We have f of x. Of course, the first thing we change f of x to y, and then we have ln of x squared minus a 9. Like I said, whenever you see ln, you must know that you are looking at log base e of x squared minus 9. So ln means log base e, and then whatever is inside is whatever inside there. And then the next thing that we do, we have our y. We interchange x and y. So where there is y, I'm going to plug in x, and where there is x, I'm going to plug in y. So I have this nice equation here. Now that I have this nice equation here, I wanted to make this y a subject of the formula. So in order for me to do that, I need to realize one thing. Whenever I have a number equal to the base raised to an exponent, this thing here is the same as saying that I have an exponent is equal to a log base a number. So basically, if this and that are the same, which means that the base is still the same, the base does not change, but the exponent is the one that goes down and the number goes inside. So this one we usually call the logarithmic form. This one is an exponential form. Here we have a logarithmic form, but in the logarithmic form, y is inside, is not the subject of the formula, and x is a subject of the formula. So we wanted to make y the subject of the formula. So we wanted to change this in this logarithmic form to an exponential form. So here, what we actually want here, you must see that whenever I have a base here, it still remains as the base here. And then whatever that number was is supposed to be an exponent. And then what is inside here is supposed to be here. So we're supposed to have y squared minus a 9. So we have changed this. So our y squared is just equal to e to the power x. I'm going to transpose 9, and then if I'm transposing a 9 here, I will end up having a plus 9. So if I am taking a square root on both sides, I am supposed to end up having, we usually have an issue around the square root, because whenever I have this, I'm going to have the square root y squared is equal to the square root e to the power x plus n9. Now, if you look into this, I have just taken the square root on both sides. And if you look into taking the square root on both sides, we cannot just say this is going to be y. What if y was negative? Right, we start to have issues now if we have y and y is negative, because if we have that, or our y is actually positive, we start to have issues. Let me make an example here. If, let's say, I have my y, for instance, is equal to minus 1. I'm just going to make this stupid case on the side here to explain what I'm saying. If I have this, y squared is going to be equal to minus 1 squared, which is equal to 1. Now, square root of y squared is going to be equal to the square root of 1. And the square root of this is supposed to give us a positive number, which is just going to be equal to 1. And this one here is not the same as that minus 1, which was y. So we cannot say that every time I'm taking the square root of a y squared, I'm going to get the same y. But if my y was equal to 1, then the square root of 1 squared is going to be the square root of 1, which is just 1, which is equal to our y. So in this case, it's only possible when y is positive. So when y is negative, this answer here actually is the same as minus times minus 1, which is equal to minus a y. So in this particular case here, we usually say that this one is going to be plus or minus a y is equal to the square root of e to the power x plus a 9, right? Now, which means now our y is just supposed to be equal to plus or minus the square root e to the power y plus a 9. I am actually multiplying by this constant here, which is plus or minus a 1. So that's why we're ending with that. Now, if you look into this, what is basically happening here, you will find out that here I have e to the power x. E is a number, it's an Euler's number, which is about 2.718 blah blah blah, and we have x here. Whenever I have an exponential where this number is bigger than 1, I know that I'm going to get a curve like that. So this is a to the power x, where a is greater than a 1. So in this particular case here, this exponential function, which is that, is always going to be greater than 1. It's always going to be greater than 0. And I take a number that is greater than 0 plus a 9, I'm always going to get a number bigger than 0. So this square root here, remember that when there is nothing, I have a 2. So whenever I have a 2 here, I know that this one is only going to be defined when this is positive. But this one is already positive for all the values of x. Hence, the domain of this square root is supposed to be x is an element of real numbers. So here, our inverse function of x is supposed to be plus or minus the square root of e to the power x plus 9. Of course, this inverse is not really a function, because every time I'm picking a value x here, I'm always going to have two outputs. So this one is not actually a function. But if I look carefully into this, I can say that range-wise speaking, if I were to split this into two, maybe take only the positive or the negative, the domain of that function means that we can plug in anything here, we're still gonna be fine. So basically, what we will actually gonna end up with is something like this, and also the domain of this inverse function is supposed to be x is an element of real numbers. So that's how we'll end up finding the domain of this, and also the range of the original function is going to be y is an element of real numbers, because we can actually plug in anything here. And also that function actually that we have, what was the function? This function actually, the range of it can actually take on any values of y. So the range can actually take that. Now let's talk about number 4. Number 4 is saying I have my f of x. F of x is equal to e to the power x divided by 1 plus 3 e to the power x. Now, of course, the first thing is going to be, I change this to y, I will end up having e to the power x divided by 1 plus 3 e to the power x. And then the second thing, I want to interchange x and y. Where there is x, where there is y, I'm going to place in x, and where there is x, I'm going to place in a y. So I have 1 plus 3 e to the power y. And then after that, I wanted to cross multiply. And then cross multiplying actually is just saying I'm going to have x into 1 plus 3ey. Because here there is a 1, then that side I will have e to the power y. And then expanding this, I will have x plus 3xey, which is equal to ey. Now, if you look carefully into this, I want everything that has a y on one side. So I'll have 3x e to the power y minus ey. This one was positive. When it's jumping the equal sign, it becomes negative. And that side, I'm taking this to the other side. So it was positive this side is going to be negative. And then I factorize here, I will end up having ey, 3x minus a 1. And then this side will end up having an x. Of course, if you take this away, this is what remains. If you take this away, and then 1 will remain there. And then e to the power y is going to be equal to minus x. But if I'm only left with that, which means this one I've divided on both sides by it. So we have 3x minus a 1. Now, I am actually looking for y here. I want to make y the subject of the formula. And y is an exponent. So if I wanted to bring an exponent down, then I need to take log of it. and this was the base, so it's gonna still be the base, and then this one will be inside here as 3x minus 1. Now a log function is always gonna be defined if what is inside is bigger than 0. Let me first write the inverse. The inverse is going to be log e. Log e means ln. I can either rewrite this as ln or leave it like that. I don't really care about the function here. I care about the domain of the inverse because it becomes the range of the original function. So to find the domain, I want minus x divided by 3x minus 1 to be bigger than 0. If I can solve this inequality, whatever the values of x that I get will be the domain of that. So how do we first find the domain of how do we actually solve inequality? The first step that we do, we change the inequality sign to equality. The second thing is we want to find the critical values. Critical values are the values of x that will make this equation equal to 0. And this equation is only going to be equal to if the numerator is equal to 0. Other words, minus x is equal to 0, which implies that I have x equal to 0. If this was greater or equal to or less than or equal to, this value here is the only value or the only critical value of this that was going to be shaded. And then again, we look for the values of x that will make this function undefined or the denominator equal to 0. So when the denominator is equal to 0, then this function is going to be undefined. So we want those are critical values. You get what I mean? Usually, most students, when they see this, they feel like, no, we don't want the denominator equal to 0. I also don't want the denominator equal to 0, but I am looking for critical values here. Critical values are the values that make this undefined. So the denominator, I want to set it equal to 0. So I want 3x minus 1 equal to 0, which means our x is going to be equal to 1 over 3. So when you are drawing the number line, whether here you have less than or equal to or greater than or equal to, the value you got by setting the denominator equal to 0, you don't shade that because that value is going to make the equation undefined. So we don't shade it. And if I found a value here by setting the denominator equal to 0, and that value is the same value that I got from the numerator, that value need to be unshaded, even though we might end up having greater or equal. So in that case, we have to unshade it, even though it was found here, because we found it here and also found it here. So we are sharing that critical value. So it needs to be unshaded, because that value is going to make the equation undefined. And then the next thing is we wanted to draw the number line. The number line needs to be there because it has marks. So here we'll end up having a 0, and here we're going to have a 1 over 3. This one here, if we ended up having a greater or equal, we're going to shade, but we only have greater, so we don't shade. This one, we don't shade it, regardless of what the inequality sign is. And then the next step is we wanted to pick values that are less than 0. I'm going to pick in minus 1 here. And then the value between 0 and 1 over 3, I'm going to pick in 1 over 4. And then the value that is bigger than 1 over 3, I'm going to pick in 1. And then I take this value here and then I plug it here. If I'm plugging minus 1 here, I will get minus 1 times minus 1. I get a 1, which is positive. And then if I plug in minus 1 here, I'll get minus 3 minus 1, which is minus. So positive divided by minus, I end up having a negative here. And then I take 1 over 4, or 0.25. If I'm plugging in that value, which is positive, I will end up having a negative in the numerator. I plug in this value here, I will end up having 3 over 4, or 0.75, which is less than 1. So I will get a negative in the denominator. So I have a negative divided by negative, I end up getting a positive here. If I plug in 1 there, if I plug in 1 here, I will get negative 1, the numerator, which is negative. I plug in 1 here, I will get a 2, which is positive. So I have a negative divided by positive, which is a negative. So looking at this inequality here is greater than 0, which means the positive. So the positive region we are looking for is this region here, which says that 0 is less than x and x is less than 1 over 3. Therefore, the domain of the inverse function is equal to x is an element of real numbers such that 0 is less than x and this is less than 1 over 3. So this is my such that this happens. So the range of the original function is supposed to be y is an element of real numbers such that 0 is less than y and y is less than 1 over 3. So that is the range of the function that was given there. Now let's go to actually the fifth function. F of x is equal to the absolute value of x minus a 3. Of course, I have my y is equal to the absolute value of x minus 3. And of course, if you look into this, our y is just equal to the square root of x minus 3, and then you're gonna square it up because the absolute value is saying that I have the square root of this. Now I'm gonna take this, interchange x and y, so I will have x is equal to the square root of y minus 3, and then I have a squared there. That's my a y. And then once we have that, what we will actually do here, I'm gonna square on both sides, right? I'm gonna square on both sides here. So if I'm squaring on both sides, because I want to solve for y here. If I look into this, I don't have actually to square, because if I'm squaring this, I'll still have that squared here, and then I will still have to take a root, blah, blah, blah. But what I can do here, I can just say, I have my x, which is just the absolute value of y minus a 3. Now, if I look at this x here, x is positive, fine. For this part here to be positive, I need, if y minus 3, this side here is going to be y is equal to minus 3, only if y minus 3 is greater than or equal to 0, or I have y greater than or equal to a 3. And then here, I will have minus y minus 3 if I have my my y minus 3 is less than 0, or I take this to the other side, I have my y is less than a 3. So I have to multiply by a negative here so that I end up getting a positive. Now that I have that, right, what is actually basically going to happen here is that I have, if I have, I'm going to actually have y minus 3 is going to be equal to x, or this actually means that I'm going to have y is going to be equal to x, because I have a minus here, so I'm going to have x plus 3 when y is bigger or equal to 3, right? And also here, I am also going to have minus y minus 3 equal to x, which implies that my y minus 3 is going to be equal to minus x, which means we're going to have y is equal to minus x plus a3 here. So this one here is actually saying that whenever our y is going to be less than a3, so if y is less than a3 here, so let us look into this, because this is actually our inverse here. So we actually have an inverse. So our inverse here is actually saying that f inverse of x is actually saying that we have x plus a3 and we also have minus x plus a3. So we have these two options, and this one here, if we look into this, if you look into this here, I want my y to be greater or equal to 3. For y to be greater or equal to 3, I want my x to be bigger or equal to 0. So here I will have x greater than or equal to a 0, right? Because if I'm plugging here a value that is greater or equal to 0, I will end up having a 3 and above. And then here, I want my y to be less than 3. For my y to be less than 3, this x here, let's look into this x. If this x here is bigger, okay, if this x here, suppose that this x here is 0. If this x is 0, then we'll end up having a 3, which is not allowed here. So we want this x to be bigger than a 3, right? We want x to be bigger than 3, or we want actually minus x to be actually less, because if we want x to be bigger than 3, we want minus x to be less than 3. In other words, I want my x here to be if I multiply on both sides here, I want my x to be actually if I want minus x to be less than that, multiply on both sides, I want my x to be actually bigger. What am I doing here? We want our y to be less than 3, right? So we want our y to be less than 3. So what we actually have here, we want our y to be less than 3. So we want minus x plus a 3 to be less than 3. That's what we want. So if I'm looking for that, I want actually minus x to be less than minus a 3, right? And if I look carefully into this, I want my x, multiplying on both sides changes the inequality, to be bigger than a 3. So I want my x to be bigger than a 3. So here I have x, and x must actually be bigger than a 3 here. So if x is bigger than a 3, this is what is actually going to happen. Let's look into this and see what actually this actually means. So here I have my x, and I want my x to be bigger than a 0, so that this one here is greater or equal to 3. Here I want my x to be bigger than a 3, so that this one here is actually going to be less than a 3. So this are the two things that we want. Now, what is the domain of this particular function here? That is the question now. What is the domain of this function here? Can I plug in negative values here? If I have a value that is bigger than 3, I can plug it here, fine. If I have a value here that is actually bigger than or equal to 0, it can be plugged. That's what this actually means, right? Now, basically, this one here, both of these two, if I have x less than 0, then here we have nothing, which means this one is undefined. So if you look into this, this actually means that a domain of the inverse is just saying x is an element of real numbers such that our x is greater or equal to 0. Right. So that's what this thing is actually saying to us. It's saying that our x here must be greater than or equal to 0, because here, according to this, we only consider this value which is greater than 0, which was kind of contained there, but we are not talking anything about negative values. So basically speaking, the domain should be that, or the range of the original function is supposed to be y is an element of real numbers such that y is greater or equal to 0. Now, I know that this one is just an analysis of this function using the inverse. Of course, there was an easy way here to do this, but I wanted to illustrate it with the inverse. We could have said that I have f of x, which is equal to the absolute value of x minus a3, and we just plot this damn thing here. And of course, if you're plotting this, it's going to be like this here. If we just plot the absolute value of x, the absolute value of x will be looking something like this, like that, right? And then having a minus 3 is just saying that I'm shifting this curve by 3 units to the right, so we're supposed to have something like that. So this one is going to be like that. So what is basically happening here, I am shifting this by 3 units. I am shifting that by 3 units, right? Let me take this out. So I'm shifting it by 3 units. So this one is y is equal to the absolute value of x. This one is y is equal to the absolute value of x minus a 3. So it's shifting it 3 units up. So if you look at this function, it starts here and then it goes all the way up. So if I were to put horizontal lines, they will cut this curve everywhere starting at 0 up all the way. So the range of this function actually is just that, because y starts here and then go all the way up. Y is an element of real numbers such that y is greater or equal to 0. So this was the easiest way to do it, but I wanted us to look into it in terms of the inverse to show that we can actually find it using the inverse function. Now let's look at the sixth equation here, which actually illustrates why you need to know all the methods of finding this so that you can actually be in a good position. F of x, which is equal to x to the power 8 divided by 2 plus 3x to the power 8. How can we find the range of this function here? So again, f of x is the same as y, so we end up having x to the power 8 all over 2 plus 3x to the power 8, and then here we interchange x and y, so we're gonna end up with x is equal to y to the power 8 all over 2 plus 3x to the power no, this is supposed to be y to the power 8, and then of course we have a 1 here, we cross multiply and we're gonna have x, and then we're going to have 2 plus 3y to the power 8 must be equal to y to the power 8. Expanding this, I will have 2x plus 3xy to the power 8 is equal to y to the power 8. I'm going to take everything to the left hand side that has a y in it. So here we'll have 3xy to the power 8 minus y to the power 8. Change the sign of this because it's jumping the equal sign. Change the sign of this because it's jumping the equal sign. So I have minus 2x. And then of course, I'm going to take y to the power 8 and factor it out. And then I'll be left with 3x minus 1 is equal to minus 2x. And then of course, I'm going to have y to the power 8 is equal to dividing by this on both sides, minus 2x all over 3x minus a 1. And then solving for this, take note that this is even number, so I will end up having y is equal to plus or minus the 8th root of minus 2x all over 3x minus a 1. For this 8th root or the eventh root, you must know that this is an even number, so this one is only going to be defined if what is inside is greater than or equal to 0. First of all, the inverse, let me write it, is plus or minus the 8th root of minus 2x all over 3x minus 1. So to find the domain of this function, what we want minus 2x divided by 3x minus 1 to be greater or equal to 0, because the 8th root of 0 is just 0. So we want it to be greater or equal to 0. To solve inequality, we want critical values. In other words, I want to first set the numerator equal to 0, which means that I'm going to have x is equal to 0 divided by minus 2, which is equal to 0. Therefore, x is equal to 0 is one critical value. I have this critical value coming from the numerator and have greater or equal to 0. So, this critical value should be shaded on the number line. Right. After we have done that, I want us to set the denominator, which is 3x minus 1 equal to 0, because it's going to make that undefined. So we'll end up having 3x is equal to 1, or x is equal to 1 over 3. This value here should not be shaded, because it's making our equation equal to undefined, right? And then after that, of course, we draw the number line. I have a 0 here, I have a 1 over 3, and then at 0 we shade this, and at 1 over 3 we don't shade it. If I pick a value here which is negative, and then I plug it here, I will get a positive in the numerator and the negative in the denominator. So positive divided by negative, we get a negative here. And then I pick a value in between 0 and 1 over 3. 1 over 4 is here. So if I'm plugging 1 over 4 here, I will get minus 1 over 2, which is a negative value. 1 over 4 here, I will get a value less than 1. So this one is negative, and the value that I will get is negative. So here I will get a positive. If I pick a value here, which is 1, I plug it here, 1, I will get a minus 2, which is negative. Plug in 1 here, we'll get a positive. So negative divided by positive, I will end up getting a negative. So we are looking for this positive region here because we have greater or equal. So that's why we are looking for a positive region here. So the domain of the inverse is going to be x is an element of real numbers such that 0 is less than or equal because it's shaded, x and x is less than because it's not shaded, 1 over 3. So our range of the original function is going to be y is an element of real numbers such that 0 is less than y and y is less than 1 over 3. That's all there is to this particular question here. That's all, nothing else. Now let's go to number, what was this? This was number 6. So we're going to number 7 here. Number 7 is saying I have my f of x is equal to ln of x squared plus 9. So we wanted to plot this, want to find the range of this using composite functions. Now, all you need to do here, look, I have a ln here. I have log base e of x squared plus a 9, because ln means log base e. I know my basic function as log e of x or log a of x. But now in the value of x, I have something sitting in there. So that thing here, let my g of x to be that function that is sitting in the value of x, which is that. So I have x squared plus 9. And my h of x is going to be log e, but in the value of this function here, I'm just going to place in my x here. Like I'm trying to track the basic function that I know. So this is the inside function that is sitting there, and then I replace it by x, I get that. So that our f of x is going to be equal to h of g of x, which is the same as just the composite of h and g. So now the second thing we do, I want us to plot this curve here, which is the inside function. So we plot that curve here. This is going to be our g of x, and then I'm going to plot this one here. So I have here y, this is y, this is x, this is x. Here I'm going to plot in g of x. This side I'm going to plot in h of x. So if I look into this function here, g of x without the 9 is supposed to look like this. But now that I have a plus 9, which means I'm going to shift this curve to be like this. But at this point here, I have a 9. So I'm shifting it 9 units up. And if I look at the range of g, I will find out that y is an element of real numbers, such that because starting here at 9 and it goes all the way up, so I will have y is greater or equal to 9. Right. So that's the range of this particular function here. Now, when I'm actually looking at h of x is log e, this value here is bigger than 1. So whenever that value is bigger than 1 and you're dealing with a log, the function look like this. And where this is, we have a 1. Where this meets that, we have a 1. So this function here is h of x, which was equal to log e of x. Now, what is the domain of this function? The domain of h is just x is an element of real numbers such that x is greater than 0, because this function is not going to touch that. Now, the next step of plotting these two functions, remember, for the inside function, we always look for the range, and for the outside function, we always look for the domain. And then the next thing, we plot a number line with the critical value here being 9. So I have a 9 here, and greater or equal to means we're shading it. Greater means we're going that side. So this is the range of g. And then for this one, I have 0, the critical value. Not equal to, so we don't shade it. Greater than 0, we are going that way. So we start there. And then we are looking for the intersection of this, of the range and that domain. Here, these two lines don't overlap. They start overlapping here. So the domain that we should be using in h should be x is an element of real numbers such that x is greater or equal to 9. So that's where we actually start. So you come to this function here and you ask yourself, where is the 9? The 9 is at this side? Not a chance. So the 9 is here. So we have a 9 there. What is the output of 9 in the function? The output of the 9 is supposed to be there. It's supposed to be log e of 9. And if you look at this domain here, it doesn't want anything less than 9. It wants things that start at 9 and go all the way here. So you remove everything that does not start at 9. So you leave this portion that started 9 and go that way. So the range of the remaining piece of the function is start here and then it goes all the way up. So we can say actually that the range of f is actually y is an element of real numbers such that y is greater than or equal to log e of 9. Or you can just say y is an element of real numbers such that y is greater or equal to ln of 9. That's all there was to this particular problem. And then this another one will be, this is number 8. We had our f of x, which is equal to ln of cosine of x. And then what we do actually, you know that this is same as log e of cosine of x. Again, looking at log e, we know y is equal to log e of x, and we know how to plot it. But there is this function sitting inside, so we just say let g of x to be that function that is sitting inside, right? And our h of x is going to be log e, and then the function that is sitting inside, we replace it by x. Why are we doing that? We do that so that our f of x is going to be equal to h of g of x, or just the composite of x. So once we have that, what this actually means for us, it actually means that for this particular thing here, we can actually get it, I mean for the range of this, we can get it by just plotting these two functions, find the range of the inside function, the domain of that, and continue with that process. So here, if I wanted to plot g of x at 0, we know that cosine goes something like this, right? And then it goes something like this. It's not that perfect, but one thing I know that this point here is supposed to be 1, and that point there is supposed to be -1. So this one is going to be my g of x, y, x. This side here, I am going to have log e or ln of x. At this point here, I have a 1, and this goes this way. The range of this function, the range of g, is just gonna be y is an element of real number such that it takes all the values from -1 to 1. So -1 is less than or equal to y, and y is less than or equal to 1. Now, when you are going to this, you find the domain of this function as I have x is an element of real numbers such that x is greater than 0. The next step is to draw the number line, and then the number line is starting at -1. I have -1 here, and then here I have a 1, and we have equal to there. So these points are shaded, and then the range is in between these two, and this range here is our range of g, which is the inside function. You come for this one, we have a 0, and then 0 is there, but it's not shaded because there is no equality there, and we go all the way there. Now, if you look at this point here, you can find out that they don't overlap. The two lines don't overlap there, and also there. They start overlapping all the way until we arrive at this point here. And when we start here, the two lines don't overlap, so we don't want that. So we want the domain to be x is an element of real numbers such that 0 is less than x and x is less than or equal to 1. So that's what we actually want, because this one is shaded, so we include it, but this one is not shaded, so we don't include it. And then after getting this domain, we go to this function here. We look, 0 is there, 1 is there, so this is the domain here, which means that we want the function that is within that interval. But once you start going all this way, it's not a part of the domain. And if you look now at this value here, it starts at x is equal to, it starts at y equal to 0, and then it goes all the way down, because when you're looking at 0 to 1, so the range of the original function f is just gonna be y is an element of real numbers such that our y is less than or equal to 0, because the remaining function here is below the x-axis, so it's going to be negative. So that's what is happening here. So that's how we end up finding that. And the last function is going to be f of x is equal to e to the power x squared plus a 2. Again, we know the function f of x is equal to some e to the power x because this is an exponential. So, but now we have this thing that is sitting in the value of x. So I'm gonna let g of x to be equal to x squared plus 2. That function that is sitting in the value of x. And then after that, I'm just gonna say, and my h of x is going to be e. In the value of this function, I'm just gonna place in x, so that my f of x is equal to h of g of x, right? Then the next thing that I will do, I'm gonna plot these two functions. So this side I have y, this side I have x. I know this one is supposed to look like this, but now it's shifted 2 units up, so it's going to look something like this. right? So I have a 2 here. The range of this function is going to be y is an element of real numbers such that y is greater or equal to 2, because this function is going to touch 2 and go all the way up. And then I draw the outside function. The outside function, I'm looking for its domain. E to the power x, e is bigger than 1, so the function is going to be growth, not decay. And if you look into this function here, the domain of this h is just going to be x is an element of real numbers. So it's going to take all the values from negative infinity to positive infinity, because I can plug in negative values here, can plug in positive values. Don't confuse this with the range. We only find the range of the inside function. The outside function, we're looking for the domain. And then if I were to look at the critical values of this function, I'm always going to have a 2 here, and then I'm going to shade 2 greater than, we're going that way. And then this one here is taking all the values from negative, positive, 0, and 2. So this one here is R of G. This one is going to be our DH. So here, these two lines, they don't overlap until we are here, and then they start overlapping, which means the domain we are looking for the outside function is x is an element of real numbers such that x is greater than or equal to 2. Now, we come to this function here, and then we look into these values. These values are negative, negative, but we wanted to start when x is equal to 2. The output at that point, we know that it is e raised to 2. But all the domain that we're looking for is going that way. The domain that is going that way, we don't want it. So the function that is on that side, we don't give a damn about it. We only care about going that side. So the range of the remaining piece here is supposed to be the range of f, which is y is an element of real numbers such that y is greater or equal to e to the power 2. So that's how you end up solving these problems, as easy as it is. Thank you very much for watching up until this far. As you can see here, we tried to solve all these problems, and all the best with your exams. Hopefully you got something here and you actually gonna use it to solve your own problems. Again, steps are very simple here. Do what you know, focus on what you know. What you don't know might not be asked. Thank you.